Good morning students, welcome back to the class. In this class we see some important geometrical results on complex numbers. So the first point, distance formula. Distance formula. Distance formula. Distance between A of Z1 and B of Z2 is given by AB is equals to mod Z2 minus Z1. Second point, section formula. Section formula. The point P of Z which divides the join of the segment, AB in the ratio M is to N is given by P of Z is equals to M Z2 plus N Z1 by M plus N. Note, if M is equals to N, then P of Z is the midpoint of AB. Therefore, P of Z is equals to Z1 plus Z2 by 2. Third point, conditions for 4 non-collinear points. Non-collinear points. Let A of Z1, B of Z2, C of Z3, D of Z4 to represent vertices of a of a first subpoint parallelogram. Parallelogram. If and only if Z1 plus Z3 is equals to Z2 plus Z4. The second subpoint, rhombus. Rhombus. If and only if Z1 plus Z3 is equals to Z2 plus Z4 and mod Z2 minus Z1 is equals to mod Z4 minus Z1. Next, third subpoint, square. If and only if Z1 plus Z3 is equals to Z2 plus Z4, comma, mod Z1 minus Z3 is equals to mod Z2 minus Z4 and mod Z2 minus Z1 is equals to mod Z3 minus Z2 is equals to mod Z4 minus Z3 is equals to mod Z1 minus Z4. Fourth subpoint, rectangle. Rectangle. If and only if Z1 plus Z3 is equals to Z2 plus Z4 and mod Z3 minus Z1 is equals to mod Z4 minus Z2. Next, fourth result. Fourth result, collinear points. Collinear points. Collinear points. Z1 comma Z2 comma Z3 are collinear points. Collinear points if and only if the first subpoint determinant Z1 bar 1, Z2 bar 1, Z3 bar 1 is equals to 0. Second subpoint, Z3 minus Z1 by Z2 minus Z1 is purely real. Third subpoint, argument of Z2 minus Z1 is equals to argument of Z3 minus Z1. Fourth subpoint, Z1 comma Z2 comma Z3 are in arithmetic progression. Next, fifth important result. Fifth important results, concyclic points. Concyclic points. Concyclic points. Concyclic points. 4 points. 4 points. Z1 comma Z2 comma Z3 comma Z4 are concyclic if and only if Z1 minus Z3 into Z2 minus Z4 whole by Z1 minus Z4 into Z2 minus Z3 is purely real. Purely real. Next, fifth result. Fifth result, triangle. Triangle. Let triangle ABC. Let triangle ABC with vertices A of Z1, B of Z2 and C of Z3, then first subpoint, centroid G of Z of the triangle ABC is given by Z is equals to Z1 plus Z2 plus Z3 whole by 3. Second subpoint, in center I of Z of the triangle ABC is given by AZ1 plus BZ2 plus CZ3 whole by A plus B plus C, where A is equals to mod Z2 minus Z3, B is equals to mod Z3 minus Z1, C is equals to mod Z1 minus Z2. Next, third subpoint. Circumcenter. Circumcenter S of Z of the triangle ABC is equal to sigma Z1 Z1 bar into Z2 minus Z3 whole by sigma Z1 bar into Z2 minus Z3. Also Z1 into sin 2A plus Z2 into sin 2B plus Z3 into sin 2C whole by sin 2A plus sin 2B plus sin 2C. Next, fourth subpoint. Orthocenter. Fourth subpoint. Orthocenter. H of Z of the triangle ABC is equal to sigma Z1 square into Z2 bar minus Z3 bar plus sigma mod Z1 square into Z2 minus Z3 whole by sigma Z1 Z2 bar minus Z1 bar into Z2 and also Z is equals to Z1 tan A plus Z2 tan B plus Z3 tan C whole by tan A plus tan B plus tan C, or Z is equals to sigma A into secant of A into Z1 by sigma A secant A. Next, sixth result. If triangle ABC is an equilateral triangle, then the first subpoint Z1 square plus Z2 square plus Z3 square is equals to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Second subpoint Z1 minus Z2 whole square plus Z2 minus Z3 whole square plus Z3 minus Z1 whole square is equals to 0. Third subpoint, 1 by Z1 minus Z2 plus 1 by Z2 minus Z3 plus 1 by Z3 minus Z1 is equal to 0. Fourth subpoint, if Z0 is circumcenter of triangle ABC, then Z1 square plus Z2 square plus Z3 square is equals to 3 into Z0 square. Note, first point, if Z1 square minus Z1 Z2 plus Z2 square is equals to 0, then the origin and Z1 comma Z2 form an equilateral triangle. Second subpoint in note, if Z1 square plus Z1 Z2 plus Z2 square is equals to 0, then the origin and Z1 Z2 form isosceles triangle. Third point, if Z1, Z2, Z3 are the vertices of an isosceles triangle, right angle triangle, and right angle is at Z2, then Z1 square plus Z3 square is equals to 2Z2 into Z1 plus Z3 minus Z2. Next, seventh result. Seventh result. Area of a triangle. Area of a triangle. The first subpoint. The area of the triangle. The area of the triangle with vertices z comma iz comma z plus iz is equal to half mod z square. Second subpoint. The area of the triangle. The area of the triangle with vertices z iz comma z minus iz is given by 3/2 mod z square. Third subpoint. The area of the triangle. The area of the triangle with vertices z comma omega z comma z plus omega z is equal to root 3/4 mod z square. Root 3/4 mod z square, where omega cube is equals to 1. Omega is the cube root of unity. So these are some of the important geometrical results covered in this class. In the next class we see some more results, some more geometrical results on the complex numbers.